Let's start by simplifying the numerator. The trick we are going to use here is to see if we can find perfect squares hidden in these square roots. That plus the product rule is the key to simplification here. So can you think of a perfect square that divides into 75? Pause and think about it if you need to. I will be here waiting when you get back. But if you're sticking with me, let's make this easy by listing out our perfect squares, and then we can choose which one might go into 75 evenly. So perfect square is just what you get when you multiply a number by itself. So 2 times 2 equals 4. 3 times 3 equals 9. Have you got the next one yet? 4 times 4 equals what? 16. Do you see any that go evenly into 75 yet? What about 5 times 5 equals and that looks like a minus sign. It doesn't look like a times. So that gave you some extra time to think about it here, I think. So you might be thinking 25 goes into 75, doesn't it? Okay, so now let's combine that with the product rule. So the way we do that is the left-hand side here is we always start with our big number, which is 75. And then we're going to try 25, the perfect square, and let that be our A number. And then can you tell me what you multiply 25 by to get 75? 3, right? Like 3/4 is 75 cents. Okay. Awesome. Now it's really easy from here. We can say that square root of 75. All we have to do now is just plug in what we have on the right hand side here, because that's equal to what we have on the left. So we got square root of 25 times the square root of 3. Can we simplify this any further before we move on? What about square root of 25? That's just 5, right? Because what number times itself equals 25? That's what a square root is, right? So we can replace that with 5. And then no whole numbers times themselves is equal to 3. So that's not a perfect square, so we can't simplify that. So let's leave it like that for now. Okay, let's move on to square root of 12. We already have our perfect squares, at least the first several of them here listed. Which one do you think goes into 12? Which one of these numbers divides into 12 evenly? 4 does, right? All right, so let's use the good old product rule again. Start with a big number on the left. And then we're using 4 as our perfect square, so we can hopefully do that simplification magic again later. And then what 12 is equal to 4 times 3, right? I know your times tables are strong. Okay, so that means square root of 12, all we need to do is substitute what we had on the left with what we have on the right. So the square root of 12 part is equal to square root of 4 times the square root of 3. All right, can we simplify this any further? I'll give you a hint. Try something similar to what we did over here with square root of 75. I think you probably guessed it. The square root of 4 is 2, right? So we can pull that out as a square root. And the same story again for square root of 3. We cannot simplify that, just as in the other part. So Now let's rewrite the whole numerator here. Since we found what square root of 75 was equal to, and we also found what square root of 12 was equal to, we can rewrite the whole numerator by substituting what they're equal to. So square root of 75 is equal to 5 square root of 3. And then what was square root of 12 equal to? That was equal to 2 square root of 3, right? So minus, don't forget our minus sign, 2 square root of 3. Can we simplify this any further before we move on? These look like terms, right? Like terms just means what it sounds like, things that are alike. So like if we had 5 boxes and 2 boxes, or say you start with 5 boxes and you take away 2 boxes, how many do you have left? 3, right? So if we have 5 square roots of 3 and we take away 2 square roots of 3, we have 3 square roots of 3 left over. So our whole denominator just becomes 3 square root of 3. Cool. So next step, let's get this square root of 3 denominator back in here, because we can replace this whole numerator with this expression we found. So the whole problem now becomes 3 square root of 3 all divided by square root of 3. So what should we do here? Can you see it? If we have the same number in numerator and denominator, can we cancel those out? The square root of 3 and the square root of 3 are the same number. So those cancel out, and we are left with just the number 3. Can you believe that this whole scary expression simplifies to just 3, and we didn't even use a calculator? Magic. If you're feeling ready for the next skill, check out the video popping up now, and I'll meet you there.